Okay, please do not fight today's lesson. It is different, but it is nicer than the lesson we just covered. And you should be right. So don't resist it. Don't say, oh, this looks like it's going to be super tough. It's actually quite nice, okay? And so what I want to do for you is I'm going to try just a slightly, no, we'll draw it out. Okay, we're going to call it f of x. And we're going to take f of x, and what we're going to do is we're going to take that area that you see bounded there, which I've shaded in yellow, that area. We're going to take it, and we're going to rotate it around the y-axis. Now, please don't draw what I'm going to draw now. You can draw what I have there, but don't draw what I'm going to draw next in purple. If I rotate it around the y-axis, watch what happens. I take that and I rotate it around. And who can tell me what shape I'm generating? A washer. Excellent. So, Morgan, per your question earlier, do you see why in this situation, do you see why I have a washer? See how this area did not connect right with the axis? So that leaves that open space. Whereas if I were to take this and reflect it over the x-axis, then it would be a disk because there's no empty space. Okay? All right. So as we consider this, you know, you would have, say, this right here, this distance would be, this would be your little radius. Agreed? Do you see that f of x is your little radius? That your little radius is determined by that function. So little radius is f of x. And then let's look at an expression for our outer radius. Our outer radius is also f of x, isn't it? So if you were to set up pi times big R squared minus little r squared, notice you would get pi times the big radius minus the little radius. And then what would happen? They'd just go away, wouldn't they? That doesn't work, does it? We need a different way. We need a better way. And so we're going to draw something called cylindrical shells. And these are actually really cool how they work out. So anybody have those? What are they called? They're like those like Christmas. You got like these dolls, or like wooden dolls they stack inside of each other. Russian nesting dolls. Yeah. Yeah. See what I'm saying? So, like, this is hard to kind of draw. I'm going to do my best. Anybody ever seen like a shell casing from a gun? Yeah. How it's really thin, right? And it's empty. So whether it's a Russian nesting doll, which doesn't really match with cylindrical shells, or like an empty casing, maybe like Tupperware stacking inside of each other. That's the type of thing we're trying to visualize here. So I'll draw it for you. Instead of drawing the rectangle going horizontally, I'm going to draw it vertically. And yes. And so what I'm going to do now is I'm going to rotate that one around to the other side. Watch what happens when I rotate this around. I'm going to rotate it around over here to that same symmetrical spot. And I get this like shell. It's like the label of a soup can, you know what I mean? And you know, we just did one of those, but we could have many of them. If I did another one, I'll try to draw one here. Take that, and I'm gonna. Do you see all these different shells that will be sitting in each other? And the more we draw, the closer they're going to stack together and everything, right? So, eventually we want to have an infinite number of those. It's going to kind of make like a bundt cake. People see the bundt cake? You like rotate it around. So what I want to do is I'm going to take the blue one and I'm going to take the shell out and I'm going to unravel it. If I take the shell out and I unravel it, what shape will it make? A rectangle, right? Yeah, it's going to make a rectangle. I like rectangles. I like rectangles. Rectangles are easy. Yeah, they are. What is the thickness of our shell? Is it dx or dy? Dx, yep, dx. All right. The original rectangle that you drew, look at the original rectangle that you drew. It had thickness of dx, right? That means that this has thickness of dx as well. Okay, so rectangle, I'd like to know the height and I'd like to know the length. What determines the height of the rectangle? The function, yeah. And then I want you to think about it. If you take this soup can and you unravel it, how would you determine the length? The same as the circumference. What's the equation for circumference? 2 pi r. And so it turns out that the volume of that rectangle right there is 2 pi times the radius times f of x dx. And we don't just want to do one of those. We want to do an infinite number and bound it from A to B. Let me show you how we come up with the radius. It's super simple. What's our axis of rotation? Y equals 0, or x equals 0. Everybody agreed? And then look at where you drew this. You drew it for some x value, right? What's the distance from x to 0? So this radius just becomes x. Not always, but almost always. Since you asked, I'll go there. Suppose we were rotating it this way. Suppose we were rotating it around 1. Then it would be 1 minus x. It's the right minus the left. See that? All right, let's try a basic problem. We have the graph of 2x squared minus x cubed, and it looks very similar to what we just drew. Okay, I am going to factor out an x squared here so everybody can see 2 minus x. It's going to cross the x-axis at 2 and at 0. Our goal is to get 2 of these done before the hour. We'll see what happens. I really want to make sure we went over a couple problems from yesterday because I knew people would have some questions there. Cool. Everybody okay with the shape? All right. I can't do a washer. Why? Because the inside radius would be the same as the outside radius. See how the inside radius is the same function as the outside radius? That says we can't do a washer method. So therefore, I choose not a washer method, but a cylindrical shell method. So I draw just a vertical rectangle. And I wrap it on over to the other side. This is so cool. I mean, it does just seem stinking impossible. But like we do it. Cool. Calculus has taught me something really neat. If I combine the volume of one shape, then I can do an infinite number. So let's just find the volume of this one shape. I don't know how to do cylindrical shells, so I'm going to unravel it and make what kind of a shape? A rectangle. Is the thickness dx or dy? It is dx. Tell me, what is the height of the rectangle? And what is f of x? 2x squared minus x cubed. How do I determine the length? The length is the same as circumference. Circumference is 2 pi times r, right? Let's determine the radius. What is my axis of rotation? X equals 0, and this is an x value right there. What's the distance from x to 0? So 2 pi x. So it turns out that if we want to go about this process, we're going to find the volume of this shape, which is 2 pi x times 2x squared minus x cubed dx. We don't want to do one shell. We want to do an infinite number. That might seem, I mean, come on, to the common person, you say you want to do an infinite number, they're like, well, that's impossible, right? Is it impossible for us? Oh, it's super easy. You just do that. And where do we go from? 0 to 2. X values. It's dx. That's a setup. I can do that. I know how to do that. How do we do that? What are you going to do first? Before you do the antiderivative. Distribute. Distribute that x through, and I get 2x cubed minus x to the 4th dx. Now the rest is clear sailing, isn't it? What's the antiderivative 2x cubed? Yep, x to the 4th over 2. And what's the antiderivative x to the 4th? It's great when we get to plug in 0, isn't it? So I'll plug in 2. I get 2 pi times what? Eight minus 32 over 5. Some people go to their calculator. We're not going to do that. We're calculus students. So I'll turn 8 into fifths. What is it? Yeah, so I go 2 pi times 40 over 5 minus 32 over 5. What's 40 over 5 minus 32 over 5? 8 over 5 times 2 pi. Sweet. I think that's easier than washers. Let's see if we can get one more done. Okay. X minus x squared is x times 1 minus x. That general shape? So to be clear, I'm trying to go with the bare bones basics of the shapes. So that's kind of a lot of times what we're going towards. Okay. You could graph it on a calculator if you don't see that. I can see it cross at 0 and 1. I just want you guys to have the general understanding of shells. Full transparency, I always try to be honest. This is actually not part of the AP curriculum. And it's not actually part of what Riverwind makes us teach. But I guarantee you every single university out there is teaching this. I promise you. You're taking calculus at Iowa right now, they're teaching that part of Calc 1. You're taking it at University of Wisconsin, they're teaching that. You're taking it at St. Olaf, they're teaching that. I try to teach you what the colleges are teaching you. You get my point? Yeah. So if you show up at Calc 2 and they start with this, you'll be like, oh, it's a breeze. And you won't drop the course like 30% of people do. So here we go. X minus x squared, we've got that. We're going to rotate it around what? X equals 2. Oh, I'm going to rotate it around this. Oh my goodness. Is that even possible? So I'm going to draw that rectangle. Instead of rotating it to the left, I'm going to rotate it to the right. Right?
Oh yeah, the line's in the middle, right?
Line's in the middle. Nice job. Yeah.
Shapes are getting progressively worse.
And I like to look at my original rectangle that I drew and just say that occurred at an X value. So we decided a shell method here. And as we have this shell method, I'm going to unravel it. When you unravel it, what shape does it make? Makes that rectangle. Thickness dx or dy? Dx. Look at your original rectangle, folks. Did the original rectangle you drew have thickness of dx or dy? Dx. Yep, horizontal thickness. That's why we chose dx. Height of the rectangle. X minus x squared. Good. How do I determine the length of the rectangle? Circumference, which is 2 pi times r, right? We need to determine the radius. Somebody tell me. I'm not rotating around 0 anymore. I'm rotating around x equals 2. What's the distance here? Right minus left. 2 minus x. Thank you. Hopefully you can see the types of problems I've been trying to show you, prepare you for these moments so that it doesn't seem just totally make-believe that happened. Okay, so if we want to find this volume, we take 2 pi times 2 minus x times x minus x squared dx. Infinite number. What are the bounds? Look at your original area. The original area we drew is right here. We'll look at the x values of that original area, and it is what to what? 0 to 1. Ooh, I like 0 to 1. 0 to 1 is nice, isn't it? Yeah. So we should probably multiply that out, huh?
Yeah.
Okay. And I know that right now some of you might feel a little anxious about that multiplying thing. Just realize this was the tough part was setting up, right? Like we know what to do now. Now it's just some algebra. 2 pi times the integral 0 to 1. And when we multiply that out, somebody help me out here. What am I going to get? Yep, I got 2x. I'm going to have a negative x squared and a negative x squared. Negative 2x squared and negative x squared make negative 3x squared. And then I have a negative x times a negative x squared plus x cubed dx. We're almost there. 2 pi times antiderivative of 2x. X squared minus x cubed plus x to the 4th over 4, determined at 1 to 0. Oh, you're almost there. 2 pi times what? 1 minus 1 plus a 4th. So you get 2 pi times a 4th, which is pi over 2, which is 90 degrees, right? There we go.
Why do we have to write it like
No. It's a joke. It's a math joke. It's not. Oh. Come on, did somebody appreciate my math joke a little bit? Come on, yeah. Carter's like, I didn't fall for it, Getz. I knew where you were going. Oh my goodness. You're ready, you guys. You're ready. Okay, shh. Okay, here's the deal. So on Thursday when we come back, okay, from your little date, we will just do one example and we'll check in on the questions. You'll have the rest of the time to work, full time to work on Friday and on Monday, but I want to be clear to you, when you get to the study guide, do not do the entire problem until you check to see if the integral is set up appropriately. Get my point? So I will...
So the work is going to be there? So we don't do it all?
For the study guide, I will put all the work there. So here's what I'm saying, Linz. Don't go to 16 pi over 5 until you've checked to see if this is correct. Then proceed. Do you get my point? Good job, everybody.